Hello, everyone. Welcome to the ICU4X workshop here at the Unicode Technology Workshop 2023. My name's Shane Carr. I'm the chair of the ICU4X TC.
And I'm Robert Bastian, and I'm also working on ICU4X.
Cool. So I'm going to start by giving an overview of what is ICU4X, what problems does it solve. And we're going to spend about 20 or 30 minutes on that. And then we're going to move on to an interactive tutorial where you can get ICU4X up and running. So yeah, that's today's agenda. So let's go ahead and get started. So first, what is I-8N? I just have two slides about this. I-8N is internationalization, which is I followed by 18 letters followed by N. It's one of the longest words in the English language. And internationalization covers a lot of different types of operations. For example, what is today's date in different calendars? This is not today, but you get the idea. So this is the date formatted in several different calendar systems. And it looks wildly different depending on which calendar that you chose. And that's one type of operation. A completely different operation that's still I-8N is finding breakpoints in, for example, Japanese text that has multiple scripts, and you need to be able to find words and separate those words. So let me talk a little bit about the I-8N stack. So the foundational piece of I-8N is the Unicode specification. We've had lots of talks this week about the Unicode specification. It gives us the foundational algorithms and character set and that we can build upon. The next layer in the I-8N stack is the CLDR, which gives us data for hundreds of locales. It gives us specs for things including message format, person names. You've heard about those this week as well. Sitting on top of CLDR is ICU, which is code that implements the algorithms in CLDR. And ICU includes ICU4C, ICU4J, and ICU4X now. Sitting on top of ICU is the platform API. This makes it easy to use I-8N from applications, including, for example, ECMA 402 and Android ICU. And then sitting on top of all that is your app. Your app can use ICU directly. It can also use ICU through the platform API. So with this in mind, let's go ahead and talk about some challenges with scaling I-8N. So the first challenge is the quadratic growth of locale data. So this is the graph of data that's in CLDR. It's one of my favorite charts. It's a little bit hard to read. So there's three dimensions going on in this graph. On the x-axis, we have the number of locales that CLDR supports. On the y-axis, we have the coverage level, which means the amount of data that is in that locale in terms of feature sets. So things like date and number formatting, collator, segmenter, all these other things. The z-axis is the CLDR release number. So as the within every CLDR release, we get more locales. On the x-axis, we also get more features on the y-axis. So this means that we have a quadratic growth of CLDR data. If you just include all CLDR data every single release, you're just going to get bigger and bigger and bigger and bigger, and it's just going to continue to grow quadratically. So that's one challenge with scaling I-8N. A second is adding more default languages has somewhat of diminishing returns because as soon as you add more data to your app, it makes the app bigger, and that means fewer people download the app. So once you get to about 60, 70-ish languages, approximately, like you might start to see diminishing returns in terms of like, well, I added data, but I increased my app size, which makes other people not want to download my app anymore. A third challenge is that we have different devices which all have different requirements. For example, you have something like a Pixel Watch, which might only have 1 or 2 megabytes of like memory that it can use. But then we also have things like data centers. The data centers, need big scale. But on the other hand, if you increase the usage by 1% in a data center, you might be using like 100 terabytes more RAM or something, which is very expensive. Then you've got things like smartphones, which vary widely across different countries. The smartphones have different types of capabilities. They might not always be online all the time. You need to be able to do things in offline client-side mode. And then you've got things like laptops, which is sort of in the middle there that have their own requirements. They might have more front-end applications. They're really focused on getting high performance, getting 60 frames per second. So all these devices have different requirements that we have to build toward. Another challenge with scaling IHN is that every language, every year, there's a new programming language that gets popular. This is a graph from like the early 2000s to today, and there's a lot more programming languages that I just picked about 10 of them so I could fit them on this graph. We've got things that have been popular for a very long time, like Java, and we've got things that have grown in popularity, like Python is most popular now; it's even more popular. And then we have some newcomers like Rust and Swift that are sort of growing in popularity, and Dart. And we want to be able to support IE10 and all of these programming languages. We want to meet developers where they are, because developers will use the libraries that are available in their programming language, and we can build a great IE10 solution for C++. But then how do we actually leverage that in all of these other programming languages? So another way that we can think about scale is, well, what if we build it as a service? Building things as a service is the answer to all problems, right? We can build all these microservices, run them on like, the cloud somewhere, and then your problems are solved, right? Well, not quite, because IHN as a service doesn't quite make sense. These are 3 reasons why it doesn't make sense. One is low latency requirements. When you're trying to do something like segmenting text or formatting dates, you don't want to have to wait for a call to the server to come back. You want to format that in 60 frames per second. You don't want to have to wait for latency in order to go call to the server every time you need to update your date format. A second is, these are data-heavy algorithms. A lot of times, like if you need to segment a big paragraph of text, you don't want to have to send that to the server somewhere. That can be a high bandwidth requirement, especially in areas that maybe don't have very good internet connections. A third is privacy implications. Especially with a lot of these latest changes to the regulatory environment. Like, we can't send user data just to some random service just to get IE10 like to do date formatting or segmentation. You can imagine, for example, taking this block of text that I showed you earlier and like sending this to some server to like do the segmentation, and then it comes back. Like, that just doesn't work. No one's going to actually use this, because it's high latency, it requires a lot of data, and it invades privacy. So IE10 as a service doesn't make sense. So what's our wish list for a scalable IE10 library? First is we want to pay for what we use and not for what we don't use. CLDR is going to continue to grow quadratically, as I showed you earlier. And if we can take a slice of the CLDR, just the slice that we need, that can really help us when we think about the quadratic scaling. And the second one is, we want to add extra locales, but we want those locales to be added on demand. Because if we just ship all the locales in our app, it's not going to help us, increase the number of users. But if we're able to add locales and have them like loaded dynamically, we can scale to hundreds of languages quite easily. A third is, we want to run on all types of devices, all the way from Pixel watches to data centers. A fourth is, we want to work in both today's and tomorrow's programming languages. We want to build a library today that, when there's another programming language that comes out tomorrow, a couple hours of time, and boom, we're supported in that new programming language. And then lastly, we want to run everything on device, ideally. We want to do everything using client-side computing. This is the wish list for a scalable IE10 library, and these are the problem space that ICU4X tries to solve. So enter ICU4X. What is ICU4X? It is an internationalization library that is, first of all, portable by design. This means that it's designed to run on all types of devices, and we have wrappers in many programming languages. Wrappers can be added easily into ICU4X to support these programming languages. Actually, part of the library, official wrappers that we, as the ICU4X team, maintain and deploy and document and test. So that's number one. The second thing, ICU4X, is it's lightweight by design. We designed it to be modular. It's great to make it great for compile time dead code elimination and data slicing. If you've worked with other libraries, sometimes every component depends on every other component. So even if you run things like link time optimization, you don't really get a lot of benefit. ICU4X is built and designed and tested to make sure that when you do run things like link time optimization, you get really good results. The third is it's secure. It's built in Rust, which is a memory-safe programming language. So we can prove things like address and undefined behavior safety. So when you use ICU4X, you can be confident that you're not introducing as many security vulnerabilities into your program. So who are we? ICU4X is a technical committee under the Unicode consortium, along with ICU and CLDR. I'm the chair of that technical committee. We have contributors from Mozilla, Google, and Amazon, some of whom are in the room right now. We have many other community contributors as well. These are just the companies that have sort of contributed the most of that work. And guess what? You could have your name on this list on this slide next year if you come talk to me after this talk. We'd love to have you on board. So this is a little demo of ICU4X running in WebAssembly. This is all running client side in the browser. I'm not doing any calls to the server here. It's all local. I'll explain what's going on here. So this is the segmenter screen. I'll wait till it switches back to the first screen. Okay, on the first screen, so I'm going to type in a number into this box, and you can see it formatted according to the English locale. I can change it to a different locale. I can change the settings. In datetime formatting, you can see the output on the bottom. I can change the calendar system. I can change the date length. I can change the locale. Here's segmenter, and you can see the result of some Japanese text being run through the segmenter there. So another question people might ask is, okay, well, this all sounds great, but can you show me numbers? Like, has ICU4X actually achieved its goals that you've been talking about this whole time? This is an example of a basic number format program that I built. It's just a little binary that goes and like takes a number and then like prints out the formatted number. That's all it does. I spent time in ICU4C, and I actually submitted some changes to ICU4C to make this as small as I could, to try to detangle it as much as I could so dead co-elimination would work before making this graph. And these are the numbers that I got out. So even after I ran, like, link time optimization and all these things, ICU4C was about 770 kilobytes of code size. And what's in that code size, in addition to like data, it also includes things like the locale canonicalizer and locale matching. It includes a lot of data loading infrastructure in this number. It also includes a lot of features of the number format that are not necessarily used by the application because they're sort of in, even after I did some refactoring to make it more sliceable, there's still a lot of pieces of the number format infrastructure that's included here. Whereas in ICU4X, we just included exactly what we needed to use. And we got a very small binary size. I believe there's about 30 kilobytes on the right and about 775 on the left. So the second graph is performance. So, okay, great, it's small, but is it fast? I took that little binary that I wrote and I ran it like in a loop to try to measure how fast it is. And again, this is code that has been very heavily optimized. I've worked on this code. Marcus and Andy and many other people have worked on this code for a very long time in ICU4C. So I'm showing these graphs and I'm sort of like, well, this is the result of a lot of work has been gone to make ICU4C as fast as it already is. It's already very fast. But we've got ICU4C on the left. We've got ICU4X on the right. In terms of the performance of the number formats, in terms of the number format operation. I've got two versions of ICU4X here. We're now on ICU4X 1.3. I didn't have time to add it to this graph before I gave this talk, but ICU4X 1.3, now that we have compiled data built in, should be even lower than ICU4X 1.2. On the right here, I've got word break. So this is the segmenter component. One of the first things people ask me about with ICU4X is, can I use segmenter? Because I really want to be able to run the segmentation, do this text layout. That's something that I've heard a lot. This seems to be a very popular feature that a lot of people want. So these are the results we have for that. Now I've broken this down on ICU4C between, I've broken it between different pieces of code that runs when you actually segments text. So in this top right graph here, the ICU4C segmenter, has, if you have UTF-8 text coming in, it has to convert it to UTF-16 before segmenting. That's a small, but it's there. But the main chunk that ICU4C has is the constructor. And this sort of reflects the data loading infrastructure that ICU4C has versus ICU4X. In ICU4X, we've built the code so that basically as much of data loading and processing is done at compile time as possible. And that's been a big part of our design. That's one reason why if you are downloading this tool, I suggest you install ICU DataGen. It's a little bit slow to install, but that's because that's the tool that includes most of the, that's the tool that does most of the work. You only run that at build time, so that at runtime, you don't have to do any of that work. We really focus on moving as much into the compile time, build time step as possible, which gives us at runtime very, very good performance. And then the actual segmentation part, which is the yellow section on this graph, ICU4X is also 20 to 30% faster than ICU4C in both non-complex and complex scripts. And this is running using the dictionary segmenter. I didn't show it. I have other graphs I can also show you, but the LSTM segmenter, which ICU4X also supports out of the box. The LSTM segmenter gives a little bit more of a trade-off between data size and performance. But they're both all the segmentation types are available in ICU4X depending on the needs of your application. So this is where I think I sort of breezed through those slides. Before we get into this section of the talk, does anyone have questions about what is ICU4X? What are the problems it solves? And we should do a mic. We should run around a mic to answer questions there.
So what's your motivation for ICU4X and 4C, and can ICU4X be ported to C or C++?
Yeah, that's a good question. So what's the future of the relationship between ICU4C and ICU4X? ICU4C remains a very popular, widely used library that's very well maintained. There's a lot of ICU4C developers in this room right now who make ICU4C a great library. ICU4X is really focused on these problems that I showed earlier in the slides. Can we build an IE10 library that actually solves these problems? 3 years ago, when I sort of pitched this project, it's like, well, can we actually build this library? Can it actually exist? We didn't know at the time. We sort of thought it might, but we couldn't actually demonstrate it. Now we've actually shown that, yes, we can actually build this thing. A lot of the things that we thought can actually happen. So ICU4X is its own library with its own development team that has its own infrastructure and own pipelines for things. It does read from CLDR to get its data, so it follows the CLDR standards. In terms of the future of ICU4C and ICU4X, this is an open conversation. I've certainly suggested that, there's certain learnings from ICU4X that we could maybe move into ICU4C at some point. It's unclear whether the point at which we can sort of start adding Rust as an ICU4C build dependency. Certainly when that time comes, it will be a lot easier for us to sort of try to tie the two together. I'm not sure when or where the timeline is for that to happen. So if you want these results now, you can get them tomorrow. You can get them today by just using ICU4X directly itself. And if you're also, another thing here is if you're concerned about what's going to be the behavior of ICU4C versus ICU4X, there was another talk this morning. I don't know if you got to see that, by Craig Cornelius, who sort of has built this test framework that actually demonstrates if there are any differences in behavior between C and X, which we've gotten them down to very, very few. It can sort of demonstrate those, so you can actually measure the differences if you're linking one versus the other library.
Yeah, and to add to that, so the X in ICU4X at the moment stands for Rust, C, C++, Dart, JavaScript, and TypeScript. So those are the languages where ICU4X is already available.
Let's run the mic. Another question?
So I definitely see the appeal of the smaller library and being able to bundle just the pieces you need, but it's also giving me flashbacks to the Node ICU install process and the nightmare of trying to get that data onto your actual running environment. How does this avoid that awfulness?
Great, yeah, good question. So the default ICU4X 1.3 includes the data, all the data that you need. And this was a pain point that we actually heard from users to be like, okay, in ICU4X 1.0, ICU4X 1.2, I can use it, but like it's kind of a lot of setup steps that I'm not necessarily ready to set up. So in ICU, so there's sort of two ways we're approaching this. Number one is in ICU4X 1.3, the default install that you just download and use in your app, whether it's in JavaScript or C++ or Rust, will just work out of the box. It won't be the optimal binary size, but it will just work and get you running. And then once you're ready, then you can sort of follow the tutorial steps to build your own smaller data files. So you can sort of separate those two steps, the step of like getting it to work versus the step of like reducing the size. The second is we have tutorials like the one that you're in right now to teach you and show you how to build that smaller data file. And we're going to walk you through step by step on how to actually do that. It's not actually that hard if you know what you're doing and you have a good conceptual mindset. And that's what we're here to learn. Yeah, from Rich.
Let's say for a minute that I'm a developer, my application is in C, and I want to use ICU4X. So what are the performance implications of calling it through a wrapper? And is there a Rust runtime or other libraries in addition to ICU4X itself that I would need?
I want Rob, why don't you answer that question?
Yeah, so Rust does not have a runtime. Rust is a very low-level systems programming language. So it uses LLVM to compile directly to whatever architecture you're on. Our wrapper at the moment has some trade-offs, but this is basically because we haven't had time to optimize it yet. So we do things like we allocate a bit more than we need to when we pass things over the FFI boundary. But these are things that can be optimized in the future.
Is there a Rust standard library?
Yes, Rust has an amazing standard library with loads of collections and all of that. We're not using most of it. So Rust has a no standard library mode where you still get access to all the good things. So it's like memory safe, you have cool things like option types, and yeah, a lot of stuff. You even get collections if you plug in a custom allocator. What you don't get is things like randomness and networking and things like this. So ICU4X is fully compatible with this no standard library mode. And this is how we get the small binary sizes as well. Because once you pull in the Rust standard library, you get things like, pretty arrow formatting, and that starts to get expensive.
One thing I'll just add to that is I didn't show it on this graph. The first version of this graph had the ICU4C bar even taller than it is now because I had also been including the C++ standard library in that bar. The Rust standard library comparative to the C++ standard library is extremely small. The standard library for Rust, the parts of it that we're using are actually included in the red bar for ICU4X in this picture. So there's no other system libraries that we're using or depending on in this graph.
A totally different question, and I apologize for monopolizing things a little bit, but you came back to this slide, and it looks like ICU4X has got some pretty big advantages, both in terms of performance and in terms of code size. Where is that advantage coming from? What is ICU4X doing that ICU4C isn't? And can we carry some of those learnings back to ICU4C?
It's a great question. Yeah, so in terms of a code size, I sort of touched on this before. A lot of the things that are in the big blue bar that you see here are things like locale parsing and canonicalization. It's possible that there could be opportunities to not include those parts of the code when they're necessary in ICU4C, but ICU4C by default, when you give it a legacy language tag, it will try to convert it to a modern one before loading from data. And this is a fairly big chunk of data and code that is included by default in ICU4C. In ICU4X, you can do it if you want, but it's not included in the default operation. The other big chunk that's coming here is data loading. So ICU4C has a fairly large amount of data loading infrastructure, which has served it really well. It runs a full fallbacking and deserialization algorithm every time that you create or construct an object, and then it also resolves what that data is. So one example here is, for example, if you're doing number formatting, you have a pattern string. So in IC4C, that pattern string is in the resource bundle file. It has to be loaded. It has to be parsed. It has to be deserialized. You have to take the pattern string and actually tokenize it into parts, do some calculations on it in order to get the thing that you can actually use at runtime. In IC4X, we've focused on doing as much of that in the pre-processing step as possible. We also, though, don't want to increase data size because there's a lot of opportunities here for like, well, if you do this pre-processing, like you're going to have, like, do you have any kind of space-time trade-off? And we've tried to avoid that as much as possible using the IC4X data deduplication mechanisms, which we'll talk about maybe later in this talk. The other aspect of perf here is, again, since we've done all of that pre-processing of data at build time, at runtime, we don't have to do it, and that's what gives us the numbers that you see, for example, on the right, on the word break graph.
All right, so let's move into the tutorial part then, and yeah, maybe that answers some of
I
your.
don't know if you addressed the performance part of that question.
Yeah, the performance part of that question was we have zero copy deserialization since we already put the data in the form that we need it. When you create an IC4X object, you don't ever allocate any memory, or you're not in most of the constructors, you don't allocate any memory because all the data is already there in the form that's required. That also helps with performance a lot. We've really focused on one thing we can do that's unique with Rust is that we can actually build a zero copy deserialization framework that we know is safe. It's possible to build one in C++, but you're going to have bugs because it's one of the it's one of the hardest problems in computer science, which is naming things and caches and cache invalidity. One of the hardest problems is sort of building, like, how can you build a really good deserialization framework that like is fast and caches things when it needs to and not when it doesn't need to, and things like this. So in ICU4X, we've been able to do that with, and the Rust programming language has really helped us to actually build this and make it work. Cool. Does that answer your question, Rich? Excellent. I'll go hand it over to Rob and we'll start the tutorial.
All right, can you all hear me with this? Cool. All right, so we're going to build a little ICU4X app now. I see most of you already have your laptops out. Some of you already followed these steps as well. The tutorial can be done in Rust or in JavaScript. So if you haven't managed to install Rust yet, you can just follow the JavaScript instructions in your browser. Yeah, what are we going to do? So we will, of course, format the date, because that's kind of the thing we do in ITNN, right? So on the command line, we just do the current time, and then on the web, we can easily add a little date picker to make it more interactive. Right, so these are the ICU4X APIs that we're going to use. We're, of course, going to use a locale to figure out what language to format our data in. And then we're going to use the date formatter. I've linked the docs here. They're also linked in the tutorial script that you can access to explore. And yeah, so that's the URL. I hope this is readable. You will have to type that out. And yeah, so we have about 20 minutes for this. Shane and I will go around and help people if you get stuck. And then afterwards, we're going to kind of discuss what we did. So yeah, we've got until 10:50 for this.
Until like 10:45, and we can start walking through.
Yeah, so 15 minutes.
We have both a Rust and a JavaScript version of this. So if you are on like a Chromebook or can't use Rust, that's totally fine. We have you can do it all in your web browser if you like.
So we either follow one of the two on your tutorial or not both, right?
Yeah, exactly. So some chapters will have two options.
Yeah. Oh, so yeah.
So you can either do the Rust part one or JavaScript.
Yeah,
part one.
I'm a little bit confused by the way that the doc kind of structured. Like, because like it's just part one and then.
Yeah, it's 2 part 1, part 2.
Yeah.
Raise your hand.
Why it's so low. Oh. It's so far along. Okay.
I'm just never used Rust. Is Rust sensitive to white space?
No,
Like that? Okay, so
it's not like that.
Okay.
There's a tool you can run, format control. Like format.
Make it pretty. How do I do that?
Just
Just run.
Just run. Basically, save your file first. It's not safe. You just run program empty, then go back to your file, and it should.
Oh, I should do that.
There is a JavaScript.
Here we go. Ready?
That makes sense. Great.
So one, yeah, I also did that. And it's like, I never had the expectation of loading.
You like that for this group. Promise me that. That's right.
That's the deprecated syntax. We still get that. Access. I imagine. Word speed. One of our favorite things is that there's most of the
Yeah, so we use the in this API,
which is
you and you.
the support folder number.
That's a really good question because I have a feature. We support the VC47 version.
Oh, I did not.
It's like, that
So
was
like-
the old standard.
Yeah, so like this is an example of the type of thing where it's like, well, one thing that ICU4X can benefit a little bit on is as you see it from the code side is like we don't have to support this. But like if you need to do this type of thing, it could be like a separate API. You can, like, for example, instead of parking it to an ICU4X locale, you can, for example, first run license for ICU4X locale equalizer on this folder. Form locale you can do form locale, and then that's that.
Yeah, like the interesting thing that we have to deal with is that we're getting lots of different devices that are, some of them are using old standards, some of them are using their own standards. And so like, so maybe kind of it's a good
That's really good up to be good.
Maybe
We should have that stitch trail because there is like another step for this. Like, I don't know if it handles the no, it doesn't support this.
So this is just. And then like that's the thing that we would need to do. This is how our still in the Levant is too short. Like we need to convert this.
Lookup markers are already available. It handles aliases, and you can use it.
Oh,
You can try using it. I don't know if it'll handle the number subject, but it will certainly handle the subject.
Is it like another cargo?
It's use IC locating locales, another one use IC locating transform. So, and then you can model a token on a budget and optimize on a locale to get the better. So you can do it, you actually still have to and then you
So the parser will.
So it does, this resolves, like, for example, resolve things like IW.
So I wanted to do before the parser rise starts.
Right, yeah, so you can try to, you can create a new locale first.
Yeah, like we're reading in a little bit.
Yeah. So you can use. Yeah, so basically what we have to do there is do go by sequence and hold the whole view.
I mean, I'm happy it's not that.
I'm really confused. What is before? So I added all this date stuff, but after adding it, now I'm getting this warning locales not being used. Or going to use variable locales. Doesn't make sense to me.
It's used.
Because this was working before. All I did was add stuff afterwards. So I.
Yeah, so you have.
Also, like I did the pretty thing and it's still.
It's not saved.
Oh, yeah, that's a problem. That might be it.
Control C to get out of there.
That's probably it. Yeah.
Do you get more
language?
You should just talk that. Yeah, just delete the whole line. It's to make the example come fast.
Oh, you're so what? That's not necessary.
It's no, it's not. It's older to make the file is just how.
Oh, okay. So that's not actually. I shouldn't have added that.
Yeah, should have added that.
All right. Maybe you might want to take that off. Because that's fine.
The problem is if you take it off, like this example, we actually violates the object short works.
Celia has that.
But and more because it doesn't know that we had.
Okay, so maybe you might want to say something like, if you're doing the tutorial, don't include this or something. So people don't. Edit by mistake. Okay, so now. Okay, now I think this is doing good.
Whole language is set up so that you do.
In today's day, these days, here we go. Let's do something more. What would be a more interesting one? Bengali. Yep.
One challenge in the tutorial that I've seen at least once, and probably other people have it, is that there's a line in, I think, was that part 2 or part 3? I think it's part 3, where there's a line that you're not supposed to include in your actual main.rs file, which is let locale equal default. Don't include that line. It's just there to make the example compile in our CI, but it's not supposed to be actually copied into your main.rs file. Just that one line. There's a comment about it.
I missed that. Sorry, on the board. Which line we're supposed to omit?
Oh, I can show you quickly.
It's only in Rust.
This line.
Oh, only.
This line we don't want.
But you use locale later.
Yes, but you already have a locale from part 2. This one.
Oh, okay. Oh, so you keep adding more to the
Yes.
to the main.
Yes.
All right. Got it.
So how you doing with your almost like I see. Like I found this example with the provider. Is that the right way? Like should I use?
Yeah, you don't need the provider because you're just creating.
How do I create?
How did you find this example? No, it's good to know that.
The first one was ICU. That's not right. And that's the same.
It's good to know that when Google search results.
Should I go to
Go to docs.rs.
It is good to see that we move on to the
Yeah, and then search for ICU. Yeah, and then that's right. That's right. Well, no, that's. Oh, that's your. Oh, wow. Sorry. Yeah. It is. Yeah, but that's the latest.
Oh, right. Fancy. Thank you.
Another good question that was just asked is that if you're looking for docs for ICU4X, the best place to go is to docs.rs and go to the ICU crate. Or you just go to our GitHub page and click to the docs link from there. This is going to give you the latest docs. The reason you know it's latest is because we look at the version number. It's 1.3. That's the latest version, 1.3. If it says some older version like 1.1 or God forbid like 0.6 or something like that, that's like an old version. Everything should be like this is an old version, but this is the new version. So to just make sure that you're looking at the latest version of the docs, which should be 1.3. Okay, how are people doing? Want a few more minutes, or do we start to review this part of the tutorial? Well, we'll have more work time later too.
Yeah, I think most people should be done with part 3. I've seen some part 4s already as well, but that's somewhat.
Let's let people try to finish part 4, at least.
Oh, because it can't parse. Yeah, not here. I mean, like, it's sounds like a really good. Like, it's not the same. Well, yes.
Looks like we have a few more people entering the room. I assume that's because the other talk just finished. Just to give you a little catch up, we started the session by going over some slides for like what is ICU4X, what problems does it solve, and now we are in the middle of the first part of our tutorial. We're all on our laptops writing code to get this to run. You can see how we've done this, and then when we start the next tutorial, we can get you all caught up if you'd like to get caught up with the coding portion. Raise your hand if you've finished at least part 4.
At least part 3.
At least part 3. Raise your hand if you finished at least part 3. Most people finish at least part 3, or at least like half people. I want to get to the point where 75% of people have finished part 3, and then we can move on. I wanted to include temporal in this example, which is better than date. Probably also your time zone. Another good question I got is if you're using the JavaScript example, depending on the time zone settings on your system, it might be showing like tomorrow's date or yesterday's date or something. That's just because JavaScript date just is not very good. And we, including myself personally, are working really hard to fix it in this new thing called JavaScript temporal, but it's not ready yet. So it's just, if you want to actually fix it, you can go in and I can work with you to do it, but it would just be, it requires writing more code. We didn't include in the example because it's a bit out of scope.
Right. So is it something in the format or the date? Oh, I don't read instructions. Yeah, right. This is I don't know. Someone dropped their flag.
If anyone dropped a black fleece, it's on the door handle outside this room.
Oh, it's just right. Cool.
Okay, for sake of time, we're going to go ahead and move on to part 2 of the tutorial.
All right. So it looks like most of you have something working. At least locales are parsing in most places I saw, and some dates as well. So we saw ICU4X is fairly easily deployed in Rust and JavaScript. You can do date formatting with it, just with all the other libraries. And we have good documentation, I hope. We also have outdated documentation on Google, which we have to remove somehow. But that's a good find. So I've got some solutions here, which we can just quickly look over and open them. So this is the mutables. This is the Rust one. So yeah, what we basically did is we read a string. This is how you read a string in Rust. Then we parse it as a locale. It will give you an error if it's invalid. Otherwise, we have a locale object now. We're getting the current date from some other crate, the time crate, because this we actually don't have in ICU4X, because getting the current date requires having like a system to give it to you, and we don't require, like, we don't have a standard library, right? We might add something like this in the future if people need that, but then it would be behind the standard library flag. So yeah, we get the date. We create our date formatter. We say we want like a medium length date. Some of you might have tried to change this to other lengths. You will get different styles of date. And then, yeah, we call format. All the expects here, for those that don't know Rust, is because most of these things return errors. And then expects basically asserts that it's not an error. If it's an error, it aborts the program. The error case here is that we don't have data for that locale. Turns out all our constructors actually come with fallback inside, so that error will never happen. We'll get into cases where it could happen later. All right, so let's talk about data. In this tutorial, you basically didn't have to worry about data at all, right? It just worked. But one of the big value propositions of ICU4X is that data is explicit. So how is this explicit? So let's look at how ICU4X manages data. So we've got this underlying trait called the data provider, which is basically an interface, so a trait in Rust that returns a piece of data for a locale. So M is a generic variable, it's some kind of marker for the type of data. So the type of data could be Gregorian date symbols. So symbols to format a Gregorian date. But yeah, so this, you can do all kinds of stuff inside load. ICU4X doesn't really care about it, right? And this gives us a lot of flexibility. Yeah, so how does date formatter actually load the data? So you created the date formatter with the try new constructor, or with the, I think, create constructor in JavaScript. This is the actual constructor. It's called try new unstable because it's not stable across versions. It's kind of internal, but public because sometimes you need it. And this basically requires a data provider that can provide these types of data. There's loads more because date formatting requires quite a lot of data. But for example, it requires symbols for formatting the time. It requires some plurals information, and the Gregorian date symbols will be somewhere in there as well. Right, so you don't want to write your own data providers generally because that's quite complicated. You can, of course. If you have an operating system and you already have data somewhere, you can use the data provider trait to expose this data to ICU4X. So you don't have to load the data with ICU4X again, because then you will have the data twice, right? But of course, ICU4X already comes with data, and it comes with multiple implementations of this data provider thing. So the first thing is baked data, or what we call baked data. So this datagen tool basically generates the data, and the data is Rust code. So it basically hard codes data into this load implementation. So it'll say something like, if language is German, return this object. And the objects that are constructed there are like completely allocation free, are the ones ready to use by the logic. And the cool thing about Rust code is that the compiler can optimize it, right? So if data is not used, then it's thrown away. If we have duplicate data or even duplicate strings, they will only put into the read-only part of your binary once. All kinds of stuff is happening there. The second data provider that ICU4X comes with is a block data provider. And that's basically a serialization scheme. So if you want to do things after compile time, you use that. So basically, you can send bytes over the network. You can send bytes by carrier pigeon, and then you can read them into ICU4X, and you have a data provider. And then what we also have is provider adapters, right? Because if you have two data providers, you need to pick one. So we have adapters to combine them, and then we have adapters to add fallback, etc., etc. So let's look at this baked data. On the right here, I have the documentation for one of our baked data structs. And it's a very simple struct. It's a zero-size type. It doesn't have any contents, but it has a lot of implementations, right? And here you see we have implementations for Buddhist calendar data, Chinese, etc., etc. And then we can look inside of one of these. They're not very fun to look at because they're generated code. But basically, we have, that's somewhat readable. We have this load implementation here. And then we have loads of static data for each locale, or like not for each locale, but these are deduplicated. But then you have like patterns in here and things like time granularity settings. But this is all like Rust code, Rust enums, ready to go. And then at the bottom here, oh my God. At the bottom here, we have a binary search through our locales. And we do some fallback if we can't find anything. So that's the baked data provider. Now, the constructor you used is just implemented in terms of the baked data provider. So this is the implementation of try new. It's just try new unstable with the baked data provider. So it uses the data that's inside the crate. If you never call this constructor, or the constructor you call try new, the baked object will never be used and the compiler throws it away. So you don't pull in the data. Right. So that's baked data. Blob data, it's not very fun to look at. It's just bytes, right? If you have really good eyes, you might be able to see some locale IDs up here and some hello world strings down here. So this is basically two lists, a couple of lists. Like it's a multi-dimensional map. We have our keys, we have our locales, we have our data. And yeah, what we do here is we create a blob data provider from the data, and then that does our data loading. What actually happens here is a bit more complicated. So the blob data provider is not itself a data provider. Instead, it is a buffer provider because now the data key is a runtime argument. So it doesn't get compiled away as nicely. Like you have to know at compile time everything you're using, and then you pull in all that code. And then we have the dynamic data provider, which does the same thing, but returns actual values. Yeah, and then we have our adapters. So this is a possible ICU4X data pipeline. You use a baked provider for some low level or some very important locales, right? You have a blob provider which can load things from the network if they're not available. The blob provider you wrap into a fallback adapter because unlike the baked provider, it doesn't do fallback itself because you might not need it, right? If you only load a single data key in a blob provider, you don't need fallback. Then you kind of merge them. You have a forking adapter that tries both. You can wrap this in something that customizes your data. So after a load, you might say, well, I actually want to replace this by this because my company says we need to do it like this. And then you pass that into the ICU4X logic, into the constructors. And then your data gets loaded from there. All right, so generating data. Where does this data come from? You've already heard about this, the ICU Datagen tool, which you can use to generate your own data. So the compiled data that you've used, like this baked provider, includes a lot of locales. It's like in the hundreds of CLDR locales, which is really cool if you're starting out or if you really don't care about size, because it just works. But of course, it doesn't give you the nice binary sizes that Shane showed earlier. So what you can do is you can select exactly which keys and locales you want to include in your data. Key selection is usually automatic, so Datagen can look at your binary and figure out what keys you used. But locales, you have to decide based on your use case. And yeah, then we have some more options here. We can, if you know that you're always going to have fallback at runtime, then we can deduplicate some things, right? Because if language A falls back to language B, then and they're the same data, then we don't need to include both. On the other hand, if we know that we don't have fallback at runtime, then we might want to include both, even if CLDR doesn't include both, because otherwise you'll get an error for some languages. Yeah, so this brings us to our second tutorial, where we're basically going to extend what you did in the first tutorial to support a locale that's not in our baked data. So baked data includes all CLDR locales above the basic level, which, yeah, is in the hundreds. But then some less supported locales are not included usually because they don't have great data. So in the second tutorial, which you can find here, you will add support for the Chakma locale, which there is data for how to format datetimes in Chakma. But it's not CLDR ready because it doesn't have data for all the other things or some other things. I don't know exactly why. Yeah, maybe if people have questions about data before we start this, we could do those now. Yes. Okay, Mark.
Yeah, I'm just wondering, how feasible would it be or what would be involved in producing a provider that read directly from CLDR XML format?
Okay, so our DataGen tool internally defines a provider that reads from CLDR JSON. And then it loads that, and then it kind of writes it back into other providers. So it's very feasible to do this from CLDR JSON. The transform from XML to JSON seems quite complicated, and we didn't want to rebuild that. Like JSON was nicer to use. I mean, so it's done, right? It's like someone wrote the XML to JSON, we wrote the JSON to data provider. So that's what's happening.
Yeah, I mean, you could in principle plug them together, run the LDML to JSON tool, and then run the ICU4X tool like in sequence, and that should be fairly automatic to work. I think, especially if we could make the LDML to JSON tool a little bit faster, especially if you only need like one locale and one data key, like, you know, I think we could get that running fairly quickly. Any more questions about data providers? Sean has a question over here.
So you talk a lot about doing this in a zero copy way with the data providers. Is that providing an implementation over whatever data is fed in, or do you need to transform that into like a common memory shape?
Yeah, so you need to transform it into the shape that ICU4X expects. So when we saw the definition here, we've got this result type, right? So each data marker M has an associated value type. This is a bit simplified. It's a bit more complicated in the actual code, but this is what's happening. So each data has a value type, and the load function returns this value type. This value type is borrowed. So it's like zero copy. It just borrows data from the provider, so there's no allocating or anything happening. And in the baked case, borrowing from the provider means it's just static data.
One question, one comment. So when you said you had baked data, and let's say I choose to have 70 locales, do you bake all 70 into the code and that's all loaded in memory? Or
yes.
Yes.
Yes. So baked data, there's the baked data that ships with ICU4X, which is hundreds of locales, like everything that's a basic or above. And then you can also generate your own baked data. If you only want to support 10 locales and you want to bake 10 locales, you generate that, you compile ICU4X with that. Yeah, and then you can load more locales later. But everything that's baked needs to be available at compile time and it's for all options.
And so, and the comment is just about the zero copy and stuff. We noticed in some instances that makes construction very quick, and you can avoid lots of ICU4C issues where people cache a lot, especially on server side. You know, when you expect to have, say, I don't know, 5,000 date formatters for specific locales and skeletons, you would have to build some local cache. And that can take like 200 or 300 megabytes of memory. If you can do it on the fly with, you know, baked in data and zero copy, that kind of eliminates need for caching. So
yeah, I think so. Going back to this, I think this bar actually contains the constructor as well. You just can't see it because it's so small. The constructor in ICU4X is basically the provider has to search for the data, but then there's nothing else to do. So it's like a binary search over, like with 5 steps or 10 steps.
It's there. It's just like half a
It's there,
pixel.
yeah.
It's like half a pixel. Yeah, well, one thing I just wanted to add to the discussion about blob versus memory and things is, so the idea with the baked data is that it's in static memory. You still don't have to do any heap allocations. We've worked really hard to avoid that. It's just in static memory. It's not in heap memory. But if even static memory is too much for you, then that's what we have blob for. Like, you know, we tried to build ICU4X so that it serves these different use cases, and you can use the thing that works best for your use case. We're very flexible about basically everything. You know, it's very modular. We don't make any assumptions. We have time for maybe one more question here, and then we should go into tutorial. But yeah, the tutorial address is here, so you can start working on the tutorial even while we answer questions.
I have a very generic question. I'm sorry I came in here only for the second half, but you're talking about data, but then whenever you mention examples, you say, okay, it's this locale or it's this locale, or you have so many locales. When I hear data, I would think, okay, so I have November the 9th, 2023 at whatever hours or so, and that's the data, and I'm going to format that with a locale, but I'm not going to call the locale data because that completely confuses everybody. So am I confused, or you're creating the confusion, or what's going on here?
So the way we use data is the data needed to do some internationalization operation.
Yeah, then I think that's a bad choice of words.
Maybe.
Yes.
Yeah, it's not the input.
Data is the real data that you actually want to, what date it is, or what place is it, or things like that. Yeah. And
it really depends who you are, I think. If you're an
and
internationalization library, then this is our
find a better
data.
word for what you call data now.
I think
and you
ship,
have a much easier life explaining it.
I think that ship might have sailed.
Okay, let's go ahead and dive into this tutorial if you haven't already started it. I think we'll pick up at 11:20 on the dot to recap this last little section. We just have a few more slides after this, and then that'll be the end of the session. So that's a little more than 10 minutes. So hopefully you've already gotten started, but we'll reconvene at 11:20. Is there anyone who still needs help getting the locale parsing set up? Because we can help you catch up. Because you'll need that before you start on part 2, on tutorial 2. What's the error?
Just as a note, DataGen will not work if you're not connected to the internet, because it downloads CLDR. And yeah, you can join the Google Guest Wi-Fi. It's open.
I can get it running just based on that download file. So, so instead of doing, so you have to pass an extra argument, which is CLDR root your downloads folder. So this is not that would just redirect this to the file. Thank you. Okay. And then is there anyone else who's getting an error TLS certificate handshake failed? One person got that. It was just, that was kind of an odd error. I have a workaround if you're getting that error.
That's on step 4.
It's not until step 4.
That's interesting.
For the purposes of the recording, the workaround to the TLS handshake error is just to download the CLDR zip file yourself that's in the error message, and then use the CLDR root command line flag to read from it.
So, that would drive the JS. How do we use it in our stuff? So I'm trying to we already use it pretty close. We don't necessarily use it. And so one of the big differences where we actually have this so this logs or means a specific giving and so you can still support it while we're independently getting back into it.
I'll also point out that like if you want to build a
Yes.
that's also the total the default that we're probably have is
So like so like because that's one reason why we have to adopt it more because we have to there's a few locales Japanese side that are public locales and there's no we can at the same time we can also try it out.
I'm
Doesn't mean I have to do that part. That's gonna take a year.
And I'm having issues where it claims that it cannot find Gregorian. Oh. All right. Oh, okay. I see what you're doing. All right. Yeah, this one is. And then rest is
Problem strategy. Yeah.
all right. Thanks.
It'll be imports.
All right.
All right, we'll move on. Yeah.
Raise your hand if you if you've gotten the blob data running or loading into your application.
Raise your
Few
hand if you
people.
haven't gotten the blob data running. The excluded middle.
Okay, I think we're going to go ahead and reconvene just so we can get through these last few slides, and you can continue working on this all afternoon if you like,
Yes, but
and
please
we'll be
pay
here to
attention
continue
now.
support. So let's reconvene and we'll go through our last few slides.
Okay, so what did we just do, or what did we just try to do? We saw that we can dynamically load a language pack if the data seems to be missing. We can also use static analysis. So if you've gotten to part 3, I think, and you use the keys for bin flag, this is static analysis to generate data for your specific binary. And then if you've gotten to part 4, we can use narrow APIs to generate smaller data. So if you use the type datetime formatter, that doesn't need nearly as much data as the datetime formatter because it only works for a single calendar. And let's look at the code quickly again. So this is as before. It's readable, yeah. But now basically we hard code, like if it's Chakma, then we do some stuff, right? We read from disk, we create this blob data provider, and then we call this other constructor try new with buffer provider. And then if it's not Chakma, then we just do the same thing as before. Both will yield a datetime formatter, which we put into the variable, and then we continue as before. Yeah. All right. Now Shane will take over from here.
Yeah, I just have this one little slide here to sort of explain some of these trade-offs. So we've got datetime formatter, which datetime formatter selects the best calendar for the locale. And the best is as defined by CLDR or by the Unicode locale extension keyword. So for example, in like English, it will choose Gregorian, and Thai it will choose Buddhist, and so forth. If you use the Unicode extension keyword, it will also choose what's in the Unicode extension keyword.
You can try that, right? If you go back to your initial app or even now, you can just use one of the like high locales and you get high with state.
Yep, exactly. Hopefully you've experimented with that already. So one thing about this API is that it accepts dates in one of two calendars. It'll either accept a date in the ISO calendar, in which case it will convert it into the correct calendar system, or you give it in the correct calendar system and then it will accept it. This is the API that you should use for best IATN correctness because it supports all of the localized formatting for all the needs of users around the world. We also acknowledge that there are some users who have like business need to be like, we're building a financial application that we only need Gregorian formatting for whatever reason. There's some business person who said we only want Gregorian formatting. So if you're in that kind of bucket, we also have another type of datetime formatter called the typed datetime formatter, which takes a calendar system as a type parameter. And it will only include the data for that one calendar system. If you've gotten to the end of the tutorial, you've hopefully seen that, where you can reduce your data size. And this sort of, this gets us to the last part of this slide, which is, when you're thinking about your data, like if you include all the data, you include both the blue, yellow, and the gray parts of this graph on the bottom, where you're including all of Gregorian, all calendars, as well as a whole bunch of other things maybe you don't need, like collator or segmenter. If you build your blob using just the keys that are generated for your binary, and you're using datetime formatter, you'll get the blue and the yellow parts, which is Gregorian and all other calendars, which is still significantly smaller than full data. And again, this is just one command line you can run in ICU4X. Like, it's taken a lot of engineering time to actually make this work, and it works. Like, it's super easy to get to this sliced form. And the third, level is like, if based on application or business requirements that you're only going to be using one calendar system as an example, you can use the typed datetime formatter, and then the data slicing will just work for that as well. And yeah, the point of this slide is just to illustrate that like this does work. It is hopefully fairly easy. The fact that that a lot of you have gotten this working just in this 20-minute tutorial, sort of drives home the point that like this does work, and it is fairly easy to do. And this is how we're able to achieve all of the small binary and data size achievements that we've gotten from ICU4X. Did you have anything to say, Manish? Or no? You have anything to say, Manish? Sorry. Yeah, that's at 11:30. We're going to move to the unconference and give the unconference.
There does seem to be lunch out there. It's not there yet.
Yeah.
Just go to the unconference thing first.
Okay.
Of the session, but you will be able to, when the voting part is happening, you'll be able to get lunch.
Cool. Are there? This is the last slide, I believe. So, are there any additional questions? We have a few questions. We have time for maybe about 2 of them.
I just quickly want to add that thingy down there is not to scale, right? You saw the sizes in the tutorial. The counters are a lot smaller.
Couple more questions. I've got Louise over here.
So for these optimizations on the reducing the data size, it's only applicable if your entire application is in Rust, right? But if you're using like the interfaces with other programming languages, do we still get those?
You can. So if you use interfaces with other programming languages, you need to do all the dead code elimination. So if you're linking statically to C, for example, you would do link time optimization, and then you can analyze that binary. So that works. WASM is a bit more complicated because there's no good tool that I know of to do this link time optimization, to like do the dead code optimization. So for WASM, yeah, like both for the size of the WASM binary and the data, we don't really have a good solution yet to slice that, because WASM doesn't have a good solution yet.
We've gotten something kind of working, and you can see like an example in the repository where we have WASM slicing kind of working. And if you're interested in doing WASM slicing, please talk to us and we can work to make it work better.
Yeah, sorry. So it's possible, but it's all manual, right? You have to manually list what you're doing, what you're using, what you need.
2 more questions, Ian and
My questions were about the JavaScript API. Specifically, will it look more like canonical JavaScript at some point? And I couldn't find docs on like how to actually install it with Node instead of just importing over the web.
Yeah, so we haven't currently published the Node package because our JavaScript API, it's not great yet. So we're kind of not ready to publish that. Yeah, but that's mainly backend things. We would like to have a nicer API. We just have to do it.
I would like to also know what your feedback is on the JavaScript API because it is designed to be largely the same shape as the ECMA402 API.
Camel case, yeah.
A camel case? Yeah, okay.
Yeah.
Just underscores lead me to distrust packages that have been made for the web because usually they weren't made for the web.
Yeah,
good feedback.
Good observation.
Good feedback.
And then my question is for how readily available is this to use on Android, like in Java files and resources?
Yeah, so there's two forms on Android. There's Android NDK. Like if you're building a native app on Android, you can currently already do that. We have people doing that for C++ Android apps that are built native. For Java apps, we would love to we would love you to join, and we have a path for how we get to Java support, and we have a bug that says this is what we have to do step by step. We just need someone to sort of invest the time to actually finish that, but we have a path for it, but it's not something that we've currently needed. So this would be a great opportunity to pitch. We are here. We're an open source project. We have contributors from many companies around the industry, and you are going to be the next one. And one example of a starter project that you could do is add Java support so we can use ICU4X in Android Java apps. And with that, we're just about out of time. So as Manish said, we're going to have a 15-minute unconference intro session in the main room before lunch. So you can peek at what is going to be served for lunch, but don't eat lunch until after we've done the unconference intro session. And thank you all so much for coming here to the ICU4X tutorial.